Hello everybody. This is second lecture of Module 2, Network Security and Cryptography, and I'm your guide Akanksha Singh, who will be taking you through the series of this lecture. We've already gone through what modulus is, basically the terminology associated with modular arithmetic. Now we'll be moving ahead to some more concepts about modular arithmetic. Let's go into straight away what congruent modulo is. Now this is another terminology that is associated to modular arithmetic. Congruent modulo. Now what do you mean by congruent modulo? Two numbers are said to be, or two integers are said to be congruent. Two integers a comma b. Now both these integers are said to be congruent when they are equivalent to each other. Now what do I mean by equivalence? See, A mod n is said to be congruent to B mod n when the equivalence value of A mod n and B mod n, the value of A mod n and B mod n should be same. That is, they should be equivalent. Only then two integers A and B are said to be congruent. Modulo congruent. Okay, that is called as congruency holding between two integers, or congruent modulo n holding between two integers A and B. So A and B are said to be congruent modulo n when A mod n is equivalent to B mod n. Right? You can also write this. You can also write this as A congruent to B mod n. Both are same. This is equivalent to this. There's no difference between A mod n equal to B mod n, or A mod n congruent B mod n, or A congruent B mod n. All same, right? And also remember one thing, when A is congruent to B mod n, then there's one satisfying condition, that is, if the value of A minus B is divisible by n. Right? So A is congruent to B mod n only when you do a subtraction between A minus n, when you divide it by n, when it is divisible by n, it is then said that A can be congruent to B mod n. Okay, so two numbers are said to be congruent modulo n when A mod n is equivalent to B mod n, or when A is congruent to B mod n if the value of A minus B is divisible by n. So let me also remember one thing. You can always mention A congruent B mod n. This can also be mentioned as A equal to Qn plus B. Okay, now this for some value Q. So you can also write down your congruency like this for some value Q. Okay, so we've understood what is congruent modulo. When you have to say two numbers, two integers A and B are congruent modulo n, you have to say that A mod n is equivalent to B mod n, or A is congruent to B mod n. And the condition that must satisfy is A minus B should be divisible by n. You can also write congruency as A equal to Qn plus B for some value Q. Okay, now let me take up an example. to explain you the concept of congruency. Here I am basically telling you that 73 is congruent to 4 mod 23. Now, what are the different meanings associated with this? The different meanings that are associated with this is, first thing, 73 is equal to some number. When you multiply 23 with some number and when you add something, only then 73 is going to come. That is, when you multiply 23 with 3, you get what? You get 69. To 69, what will you add to get 73? To 69, what will you add to get 73? The answer is 4. The answer is 4. Right, so basically here you can see that 73 is equivalent to 73. Got it? Therefore you can say that 73 is congruent to 4. Therefore you can say 73 is congruent to 4. And there should be a necessary condition that 73 is congruent to 4, which is 73 minus 4 should be divisible by 23. Is it divisible? 69 is divisible by 23 by 3 times. Right? Okay, let me explain once again. I have already been given with this. 73 is congruent to 4 mod 23. That is, that 73 mod 23 is equal to 4 mod 23. That is, 73 is congruent to 4 mod 23. Now, you can also write this. You can also write this like this. Remember, what did I say? You can write your congruency like A is equal to some value n. N is what here? In my case, n is 23. So I have written 73, that is my A, equal to some value n plus b. Here it should be b, right? Here it should be b. So what did I do? I asked you what should be multiplied with 23 to get the nearest value to 73, nearest and smallest value to 73, nearest and just the small value, right? So when you multiply 3 with 23, you get 69. When you multiply 4 with 23, you get a higher number than 73. And I want a number which is lesser than 73. So I picked up 3 and multiplied it with 23. I got 69. To 69, when I add 4, I get 73. Therefore, now can you see that this condition here matches with this? Why did I say you can write it like this? Just to illustrate you that here 4 is going to definitely come. When you multiply something with 23 and when you add it to 4, you are going to get back 73. Right? And then I also told you that if you know that 73 and 4 are congruent, it must also follow this rule as we have seen. So 73 minus 4 divided by 23. That is 69. 73 minus 4 is 69. 69 divided by 23 is going to give me 3. Therefore, it is divisible by n. Right? So, 73 and 4 are congruent. This condition is true. Here, when I mentioned 73 is congruent to 4 mod 3, my purpose was to find out whether 73 is congruent to 4 or not. Let me take another example. Another example is 21 congruent minus 9 mod 10. Okay, so this is the example, right? How will I write it again? Again, I will take the form of A, Q, N plus B. What am I going to do here? A is my 21, N is my value 10, plus I know B should be there, and I should multiply with 10 some number to get the number lesser than 21. Here when there's a, one more thing I would like to tell you, when there's a minus integer value, when there's a minus a value, it should be a number just greater than 21. It should be a number just greater than 21. So when you multiply 2 to 10, you get 20, which is less than 21. For minus value, it will not be lesser than 21. It will be just the bigger number than 21. So when you multiply 2 with 10, it is going to give you 20, which is lesser than 21. So not acceptable. You have to take 3. When you multiply 3 with 10, it gives you 30, which is greater than 21. Just next 21, 30 is the greater value, right? So now when you multiply 33 with 10, you get 30. Now to this, when you perform minus 9, it gives you back the value of 21. Therefore 21 is congruent to minus 9, correct? Since you can write this expression equivalent to this, therefore you can say that 21 is congruent to minus 9. One more condition that must satisfy is that a minus b, that is 21 minus 9 divided by n should give you a divisible number. So when 21 minus 9 is performed, you get 30. 30 by 10 gives you 3, right? So the condition is satisfying. So basically, whenever there's a congruent equation given to you, what you can do is you can first see whether you can write the congruent equation in this form or not. If you can write this, good enough. The second thing that you have to see is this condition meets or not. Okay, and one more thing that you have to keep in mind is your value of a. If your value of a is positive, it is good. You have to find out just the lesser number. If the value of a is negative, then you have to find out just the bigger value than this. Okay, I hope you can understand what I'm trying to say. Let's move ahead to more understanding of what congruent is. Now, congruency. If I have to take the number line and then explain you what congruency is. Just now I told you that 21 is congruent to mod 9. Just now I told you that 21 is congruent to mod 9. Or you saw that 73 is congruent to 4. Let me take up an example that 21 is congruent to minus 9. See, this is a number line. Can you see this is the number line? Yes. Now, if I tell you to find out all the numbers that are associated with 1, all the numbers that are associated with 1, right, this is one number is associated with 1, this is another number associated with 1, this is another number associated with 1, this is another number associated with 1, right? Okay, let me first tell you how I have written this number line. See, what have I done is for a modular arithmetic 10, if there is a mod 10, how can you make the number line? Basically, for mod 10, you have to repeat numbers from 0 to 9 again and again. Modular arithmetic is a circular arithmetic. When you say mod 10, it means from your answer will always be between 0 to 9. When it is mod 3, your answer will always be between 0 to 2. When it is mod 4, your answer will be always between 0 to 3. When it is mod 5, it is going to be between 0 to 4, right? So when it is mod 10, your answer is always going to lie between 0 to 9. There's no doubt between this. So the upper numbers are going to have the repetition from 0 to 9. I have written 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I've again repeated 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I've again repeated 0, 1, 2, 3 up to 9. Similarly, at the other side, I have mentioned numbers from 9 to 1 and then again repeated my number line from 9 to again going forward. Okay. 0, 9, 8, 7, 6, 5, 3, 4, 2, 1, 9, 2 1, I'm sorry, 2 1, this will be 0 class, and then 9. Okay, 0, 9, and moving forward. Now, this is the upper part. I hope you've understood the upper part. The upper part is going to be your answer, because it is always between 0 to 9. Okay, now the lower part. This is the mid value where you have mentioned 0 first time. Now, this side is going to be the numbers, the positive numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to whatever demarcation you have made for modular arithmetic, and this side is going to be negative numbers up till whatever demarcation you have made for modular arithmetic. Right? Have you understood? Let me repeat once again. This number line, how have I made this number line? I have first seen what is my mod n, what is my modulus. My modulus is 10. For 10 modulus, the answer is going to be between 0 to 9. Since it is going to be between 0 to 9, what have I done? I have made a number line with the upper values between 0 to 9, and then repetition again 0 to 9, and I have repeated 0 to 9 pattern at the upper side, and at the lower side I have mentioned the numbers. 0, from 0 to positive side I have mentioned all the positive numbers, and from 0 to negative side I have mentioned all the negative numbers up till wherever I have made the demarcation of modulus value. Now, to find out whether 21 is congruent to minus 9 or not, first find out what is the value of minus 9. What is the congruent value of minus 9? See here, for minus 9 the congruent value is 1. For minus 9 the equivalent value is 1, as you can see here. For minus 9 the equivalent value is 1. So wherever 1 comes, all those values are congruent among themselves. Wherever 1 comes, all those values are going to be congruent among themselves. That is, minus 9 is going to be congruent to 11. Minus 9 is going to be congruent to 21. That is what we have seen here. See, for 21 also the value is 1. For minus 9 also the value is 1 in modular arithmetic. For minus 9, 1 also has the value 1. For minus 9, 11 is also congruent because that also has the value minus 1. Please let us check. Let us check with this rule that we have taken here. Now, is 1 congruent to minus 9 mod 10? According to this number line, yes, this is true, right? Now, let us check with this method that we have done before. 1, how can you write this number in the form of A? How can you write this congruency in form of A is equal to Qn plus B? 1 is equal to 10 plus some value. What do you multiply with 10? That gives you just the bigger value than 1, which is going to be 1 here. 1 into 10 is going to give you 10, which is bigger than 1. What are you going to do here? Here you should do something which gives you the value equivalent to 1, right? So here if I perform minus 9, I am going to get back my value 1. Therefore, these two numbers are congruent. And when you perform 1 minus 9, 1 minus minus 9, it gives you 10, and 10 divided by 10 gives you 1. Therefore, 1 is congruent to minus 9. And by this number line also you can see that minus 9 is congruent to 1 because both the values of minus 9 and 1 in the modular arithmetic is 1. Now, please check for 11 also. Let us check for 11 also. Is 11 congruent to minus 9 mod 10? How will we check? We will again write this in the form of A is equal to Qn plus B, which is 11 11 equal to 10. You have to multiply this with some number and then add some number. So what do you multiply to 10 to get just the bigger value 11 with the 11? That is 2. 2 will give me 20, and if I write here 1 will give me 10, which is smaller number. So 2 into 10, that is 20. And now what do you do to 20? If you do minus 9 to 20, you will get 11. Therefore, this is true, right? Because you're going to get 11 back. So this is true, right? And follow the rule of a minus b divisible by n. If we follow the rule of a minus b divisible by n, what you're going to do is 11 minus 9 will give me what? 11 minus 9 is going to give me 20. And 20 divisible by 20, yes, it gives me back as 1. Therefore, this condition also satisfies. So this is all about congruency. Basically, when you say that two integers are congruent, it means that a mod n is equal to b mod n, or you can say a is congruent to b mod n. When you say a is congruent to b mod n, you can write this form of a congruent b mod n. A is equal to qn plus b. Right? This is also the condition, and this is also the condition. These two are the conditions that should be met for the congruency to hold. So for each of these questions, what have I done? I have first written this congruency in this form. If this congruency is, if this form is equivalent, that is A is equal to Qn plus B. If 73 is equal to 23 plus B plus some number into some number, that is they are equivalent, plus this is another condition. So both the conditions must satisfy for all the congruency. We also saw a diagrammatic explanation for what congruency is. Basically, I told you if you take mod 10, your answer is going to be between 0 to 9. So what I mentioned here is the number line between 0 to 9. If you have to find out something for suppose mod 23, then you have to write down the number line between 0 to 22 again and again. So you can just imagine that your number line is going to be huge, and you cannot make this number line again and again, right? Therefore, all these methods have been proposed to find out the congruency easily, and not this number line is used, because this is going to be complicated for huge modular arithmetic. Okay, but for understanding, this is necessary. Moving ahead to the properties of congruency. Now, what are the properties of congruency? There are three properties of congruency. The first property says that A is congruent to B mod n if and only if A minus B is divisible by n. A minus B is divisible by n, right? Well, all of us know this. We've already seen that this is the compulsory condition. Okay, so this is the first property. The second property says that A is congruent to B mod n. This implies that B is also congruent to A mod n, right? There's no problem in it, right? You can exchange A and B here. It is one and the same. Come back again here. A mod n should be equivalent to B mod n. If you write A is congruent to B mod n, you can also write B is congruent to B is congruent to A mod n. There's no problem, because both are going to be equivalent, so that you can exchange A and B anytime that you want. So this is the second property. The third property says that A is congruent to B mod n, and if B is congruent to C mod n, right? If A is congruent to B and if B is congruent to C, then you can also say that A is congruent to C mod n. These are the three principles, these are the three properties that will always hold for congruency. One is if A is equivalent to B mod n or congruent to B mod n, then A minus B is always going to be divisible, completely divisible by n. And if A is congruent to B mod n, then this implies that B is also congruent to A mod n. Always remember that this is the property, set property for congruency. Third is if you can say that A is congruent to B, and if you can say B is congruent to C mod n, then you can also say that A is congruent to C. Moving ahead to modular arithmetic operations. Now, what are modular arithmetic operations? As you can see here, there are certain modular arithmetic operations or modular arithmetic exhibits certain properties. Now see, what properties does modular arithmetic represents? See, if you perform A mod n addition B mod n to the whole, you do mod n, then you can simply write this line like this: A plus B mod n, right? When you add A mod n to B mod n, you can write this as A plus B mod n. Another property says A mod n minus B mod n whole mod n can also be written as A minus mod n. Okay. Another property is A mod n into B mod n whole mod n can also be written as A multiplied by mod n. Right? So these are three properties that will always hold for modular arithmetic. If there are two modulus that are added to the same modulus, then A plus B mod n is same. If there are two modulus, A mod n minus B mod n to the whole modulus n, then A minus B mod n is equivalent to the previous one. Similarly for multiplication. Can we move ahead? Okay. So these are properties that are exhibited by modular arithmetic. These are properties that are exhibited by modular arithmetic. These are also some properties that are exhibited by congruency, and these are certain properties that are exhibited by modular arithmetic. Okay, earlier we had studied the properties of congruency, and here we are studying the properties of modular arithmetic. Okay, moving ahead. To what laws are held by modular arithmetic? What laws are held by modular arithmetic? The first law that holds is commutative law. How can you write commutative law? You can say that W plus X mod n is equal to X plus W mod n. There is no difference. Okay. You can also write that W into X mod n is equal to X into W mod n. This is commutative law. Okay. I hope there's no confusion. Next is associative law. What does associative law says? Associative law says W plus X plus Y mod n is equal to W plus X plus Y mod n. Both are equal. Okay. There's no problem writing this or this. They are same. Similarly, you can write multiplication. Similarly, you can write this for multiplication is equal to this is associative law. Now distributive law is when you can write W into X plus Y whole mod n as equal to, you can distribute W into X plus W into Y mod n. Right, this is distribution law. What are identity law? What is an identity law? Identity law is that when you add 0 to W and perform mod n, it is equal to W mod n. Okay. Or when you perform 1 into W mod n, it is going to be equal to 11 mod n. Right. For addition, the identity element is 0, all of us know. And for multiplication, the identity element is 1. That is all. That is very clear. Right. Additive law. What do you mean by additive law? Now, additive inverse. Now, additive inverse says for each W that belongs to a set Z. Z is a set of elements. W belongs to a set of elements. There exists a number in Z such that W plus Z is equal to 0 mod n, which is equal to 0. That is called additive inverse. Okay, this is a little different. Now I am saying that W is belonging to a set of elements, right, to set of elements Zn, such that there should also exist a Z such that W plus Z is equal to 0 mod n. That is additive inverse. I just now mentioned Zn here, right? I hope this was not very clear to you. I'll be explaining more on this. Now, I said that for each W that belongs to Zn, there should be existing a Z value. There should be an existing Z value such that W plus Z is equal to 0 mod n, which is equal to 0. Now, what is Zn here? Now, for each integer, this is a Zn value here. Zn is a set of elements as written here. 0 into 0, comma 1, comma dash 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 up till n minus 1. Now for each integer in Zn represents a residue class. So Zn is a set of elements that is a residue class. We can label modulo n. You can label modulo n here as 0, as 1, as 2, as n minus 1. Let us take for mod 3. For mod 3, you can make your number line like this. 0, 1, 2, 0, 1, 2, 0, 1, 2, and here also 0, 2, 1, 0, 2, 1, right? You can write it like this. I hope you do not have doubt. And here below you can write the numbers. Here, from here you will write the positive numbers, and from here you will write the negative numbers, right? Now when you have to find out if remainder is the class, what is going to be the congruent values here? For 0, what are the congruent values? 0 is the congruent value, 3 is the congruent value, 6 is the congruent value, 9 is the congruent value. On the negative side, you can say minus 3 is the congruent value. You can say minus 6 is the congruent value. Minus 9 will be the congruent value, as you can see here. So these are the remainder class that is mentioned in Zn. These are the remainder classes that is mentioned in Zn. So for 0, these are the congruent values. For 1, what are the congruent values? For 1, you can say 1 is congruent, 4 is congruent, 7 is congruent, 10 is congruent. On the negative side, minus 2 is congruent, minus 5 is congruent, minus 8 is going to be congruent, right? So for 2 residue class, what are congruent values? For 2 residue class, the congruent values are, you can see here, for 2, minus 1 is the value, minus 4 is the value, for 2, minus 7 is the value. On the opposite side, 2 is the value, 5 is the value, 8 is the value, 11 is the value, as you can see here. So this is all about Zn. If Zn is the class that is given, Zn means Zn represents the residue class. Residue class is each of the element in Zn. You can mention it, you can label it as a remainder, and you can find out the congruent values for the remainders. I hope you've understood this. So I'll be ending my lecture here. This is all about the congruent modular arithmetic. We'll be talking about modular exponentiation in the next video. Please stay tuned to all my videos to understand the entire concept of modular arithmetic. Thank you. Thank you so much.